Sanbonani, good evening. Kuyanand, good evening, Tobel. Professor Daniel Mashau, Executive Dean, Faculty of Engineering and the Built Environment. And every time I meet Professor Mashau, I remind him that we studied at the same university. He might be a little older, but we studied at the same university. And I'm catching up, I'm becoming gray, so joining. And Professor Madindwa Mashinini, the inductee, and I was telling him that actually I know that he is named after the Mashinini ancestor. And so I do my homework, Prof. Professor Munish Gupta, Associate Professor at the Faculty of Mechanical Engineering, Opole University of Technology in Poland. Senior leaders of this great University of Johannesburg, members of Senate and other academics present. I saw Professor Stoll, oh yes, I saw her over there. And all who have joined us online, Sanbonani, Huyenan, good evening, Tobel. They say here the University of Johannesburg, all excellence observed. And so it covers all of you excellent people who are here. So it is indeed a great honor and a special privilege for me to welcome you to the Professorial Inaugural Lecture of Professor Madindwa Mashinini. And the professor was asking you whether the madam is present and kids, and he told me not only are they present, but his mother is also here. Just a special welcome. So as I welcome you to this great university this evening, I wish to express a warm welcome to your loved ones, Prof, especially your wife, kids, and your mom, to the special guests and to the colleagues. This is indeed a proud and joyful, and yet a landmark moment for all of you, for Professor Mashinini today, and for us here at the University of Johannesburg, but also for the higher education sector in South Africa and beyond. Now, people ask, what is a professorial inauguration? The inauguration of professors is a public ceremony in which newly appointed professors are inducted into office by the Vice Chancellor, and I'm standing on behalf of our Vice Chancellor this evening, Professor Lihlokwa Mpedi, who's currently in Namibia, and so he asked me to do this, and I feel all important this evening to deliver this inaugural address. This ceremony has its roots in the medieval university, and it serves multiple purposes, and I will speak about some of them this evening. First, it is an expression of welcome and an entry for new professors joining the circle of colleagues who are already professors. That is the first purpose. Secondly, it provides a platform for professors to display their expertise in the discipline and to showcase their research. And I was reading Professor Mashinini's inaugural lecture today. I can promise you it looked all excellent, even though some of it I couldn't understand it. But I'm sure he will explain it to us. This evening. In the colonial tradition subscribed to by many universities, assuming the role of the professor refers to the gown and cap. And you'll see we'll do something about the gown and cap towards the end. Once we have listened to the inaugural address, the gown denoting the professorship will formally be assumed by Professor Mashinini. Today, we gather to witness Professor Mashinini's entry into the illustrious community of scholars at this great University of Johannesburg. We celebrate his contributions to the discipline and ultimately his impact on society. Professors provide a university with its identity, its character, its academic legitimacy, and its integrity. The inaugural lecture is a rite of passage following the confirmation of the appointment of a person as a professor. This evening, we'll listen to Professor Madindwa Mashinini as the gown goes to town. By this, I mean that the power of the inaugural address is when the expertise is showcased beyond the corridors of the university and reverberates throughout society. It stands out as a moment of pride for the incumbent, his family, fellow scholars, the university, and ultimately society as a whole. In the past, several philosophers and scholars have defined universities using very narrow conceptualizations. For example, they say the university is for truth, for universal knowledge. Even universities serve as instruments that serve the purpose of the economy or being just utilitarian in nature. Through our work and research at this great University of Johannesburg, we hope that we can break out of these narrow conceptualizations and reflect on the university as contributing to the public good, working towards societal impact. What is the role then of the intellectual? Since today we are inaugurating an intellectual, what is the role then of the intellectual? Edward Said, in one of his articles, defines the role of the intellectual as one who commands a vast knowledge of a specific discipline, one who's rigorous in the analysis of literature, one who views being as an intellectual as a vocation, and one who functions as a kind of public memory to recall what is forgotten or ignored, to make the connections that are otherwise hidden, and to provide alternatives for mistaken policies. It remains then for us as a university with a Pan-African vision to derive our mandate as intellectuals and as professors. And importantly, how do we embrace the role of a professor as a disruptor while continuing to be flagship carriers of our disciplines? This evening, we'll listen to Professor Mashinini as one step further in the journey of being a professor. This is a journey which does not conclude once this lecture has been given. Notwithstanding, this inaugural lecture does create an opportunity for a self-reflective pause, Professor Mashinini, in your journey as a professor. Now, as I conclude, I would like to invite the Executive Dean, Professor Daniel Mashau, to introduce Professor Mashinini. I thank you, Rialibocha, Giabonga, Payatanki.
Good evening. It's really my pleasure this evening to introduce to you Professor Mashinini. Professor Mashinini has provided for us his CV. I will be telling you a little bit about him, and I'm very impressed, Prof, when I see the journey that you have taken to this level at the University of Johannesburg. It's really our joy that we are part of the people that we have decided to become and to contribute to. Professor Peter Madindwa Mashinini developed his interest in academia when he commenced his studies in the field of mechanical engineering when he registered as a full-time student at the previous Port Elizabeth Technikon, which changed to Nelson Mandela Metropolitan University and currently known as Nelson Mandela University, NMU. In 2007 and 2009, he graduated with National Diploma and B.Tech, respectively. During his undergraduate studies, he was a busy student involved in the Sasol mini-bug competition in 2005 and 2006. He focused career interest during undergraduate studies within the field of friction processing, started as a research assistant at ENCHA, a research and innovative center situated in NMU in what is now called Gqeberha. In the beginning stages of his career, he was mostly involved with strain gauging of components for stress analysis, material testing, and evaluation of materials after testing. In 2009, he registered for an MTech qualification with a research project entitled Process Window for Friction Stir Welding of 3 millimeter titanium alloy. If you are following my reading of the script, you will see that it's not titanium alloy, it's titanium, 6AI, aluminium, and many other things that I couldn't pronounce. So I had to call him today and say, Prof, give me what I need to say, not this complicated letters, which we agreed I should say, just say titanium alloy, and I'm comfortable with that. After completion of this qualification, he registered for a PhD qualification in 2010. The research was based on investigation for establishing the fatigue life of friction stir and laser beam welded titanium alloys at different heat input rates. There is a high demand for driving the technology transfer of friction stir welding over the world and laser processing technologies, with particular focus of keeping the South African engineering industry up to date with the latest trends of material processing technologies. The PhD research project provided insights regarding the implementation of friction processing and laser processing as an innovative engineering technology for our local industry. Professor Mashinini served as a part-time lecturer at NMU, teaching strength of materials, mechanics of machines, mechanical engineering drawing, and motor vehicle engineering modules for the undergraduate curriculum. In 2015, Professor Mashinini joined the Department of Mechanical and Industrial Engineering at the University of Johannesburg. He was involved with the undergraduate teaching of National Diploma and B.Tech students. He concurrently was involved in a supervision of postgraduate students as well as hosting PDRFs, postdoctoral research fellows. In 2016, he was promoted to senior lecturer, and in 2020, he was promoted to associate professor. And due to his contribution in academia, especially at UJ, and nationally and international engagements, he was promoted to full professor in mechanical engineering. Professor Mashinini was also appointed head of Department of Mechanical and Industrial Engineering Technology Department. He served as HOD from 2017 to 2024. He is currently acting as a Vice Dean Teaching and Learning at the Faculty of Engineering and the Built Environment at UJ, which I might add, the largest Faculty of Engineering and the Built Environment in the country. So he's serving at a big institution. Professor Mashinini has been involved in many capacities, being on the ethics committee, the engineering science committee, and also due to his role, he has to chair some of these committees and participate in several committees. I won't be able to go read all of them, Prof. They will take many more hours if I were to read all of them. He has published several research articles that include peer-reviewed papers presented at conferences, over 60 articles, 11 peer-reviewed book chapters, and over 60 peer-reviewed ISI journals. He has hosted over 6 postdoctoral research fellows at the university. He is currently rated by the NRF, by the National Research Foundation, as a C2 researcher. His area of expertise is in materials processing, welding of materials, and development of composite materials, additive manufacturing, and advanced machining processes. You will understand all of this when he gives his presentation. Professor Mashinini is a professionally registered with the Engineering Council of South Africa as a professional engineering technologist and is a member of the South African Institute of Mechanical Engineering. He has been heavily involved with EXA in terms of engineering programs, accreditations, programs, endorsement, and reviews, as well as professional reviews. We look forward to further engagements with him at the University of Johannesburg in many capacities that he'll be working in. We're looking forward, Prof. Mashinini, to postgraduate supervisions, research publications, and increased performance of our undergraduate students, and also contribution to the Sustainable Development Goals. Today, Prof, you have joined a group of professors of excellence and greatness at a great University of Johannesburg. Thank you. That's the introduction of Professor Mashinini.
Good evening. First, I wish to give thanks to Almighty for providing us the opportunity and the blessings to be here for us and the family and friends at large. Thank you, Prof. Nguluga, in your capacity as a VC today, Vice Chancellor, Professor Mashao, the Executive Dean of the Faculty of Engineering and the Built Environment. I did see Prof. Shongwe as well is here, the Vice Dean Research and Innovation. The HOD of my department, Dr. Mfundo Ngosi is here, the head of school is here as well, Dr. Gzibani. And maybe I shouldn't call everyone, otherwise I'll get in trouble. And the members of the faculty and other members from other faculties as well, from various levels of their capacity. Special or great thanks to the University of Johannesburg for creating the opportunity to grow or for growth and excellence. We are here. I'm here to share my journey of professorship from the PhD exit until this point of the professorship. So maybe I should. The topic for today is advanced materials and sustainable processes for a new world. It's a journey of academic involvement in this field of material science and processing. So I'll just highlight, this is just some of the things that I'll be talking about. I'll not go one by one. So, it's going faster. I'll start with my background. I always say, as a person or as individuals, we are who we are because of the people that have been here before us. That will be our parents or the elders and the grandparents and so on. The list goes on. So it's always great to start your journey to know where you come from. So I am Madindwa, Schabela, Makonza Goduge, Indaba is a... Yeah. Bablala umuntu bamhleka, Betty... Yeah. So I just wanted to give you a glimpse, but you will end with it. I just wanted to show you that, like Prof Nguluga said, where he's already done his homework, he knows where the people come from. Yeah. As I start this journey, those who are close to me, they also know that I like referring to a person as a villager. So that is a true fact because we raised and we grew up from the shadows of the great mountain, Khobaleabua, which shows, okay, I'll put a translation for you there for those that will not understand. But it's just you enjoy the scenery of the sunrise and the sunset, which gives you that hope and the vision that you, depending on which side are you, there's always hope and light towards the end of or from where you are sitting. Hence, I put that picture for you. It's always befitting to know. I'm sure you can see there are two pictures there, or a picture that shows two people. So it's always good to acknowledge where you come from or your parents. So I'm starting with that for now. Normally we'll put that at the end. But there's a lot of pictures that just indicates I've enjoyed the graduation from an early age. We can see there's been a various graduation even from a lower level there. But I'm sure you are able to see who's there on the first one that at that lower level. You can always see there's a taller person than more than anyone else. So this is just to highlight my alumni, where I've been in terms of school and tertiary. Some of I should just acknowledge the rector of one of the school or the institution, Rotori Polytechnic, is here amongst us. Thank you for your presence. Professor Spiriti Tladi is there. So I always say the journey or the career journey is not always smooth. So there's always zigzags in your life, or there's potholes, but this is just showing the trajectory of the journey so that you can see it has been quite a long way without pinpointing one by one what was what. So it's always befitting to just give you a glimpse of research. So I've been pretty busy. You can see there are some number of articles that were indicated there. I will not go one by one. In terms of where I do the work, it's just listed there. Most of the items are in material science and engineering, but there is coverage of other items. As an academic, it's always important that as you enter, I always say my philosophy is to assist others until they get to the point where they finish their studies, and even probably assist them to get to the workplace or industry. So like anybody else, when you are starting your career, you always have to knock at someone's door, so that they can create a path for you where they will provide assistance until you exit it. Some of you have seen this image. There's more to read than what you see. So my former supervisor said, when I approached him, he said, "Do you know what you are getting into?" Then I said, "I'm not sure, but I just want to do it." So, but it's up to you or it's up to me and you to prove a point. So you can see in my earlier days, I was pretty fresh. My bald patch was not existing yet there. So maybe the whole research caused the loss of hair there. But that's when that picture was somewhere in 2008. So when the story of research started. But I always say, like the forefathers did, they moved from Eswatini to Mpumalanga to KZN, to Lesotho, to Free State, looking for their grazeland or shelter for their families and animals. So even myself, I think I'm following a similar journey to have crossed a number of rivers, because I crossed the Orange River to the Eastern Cape to pursue the education. Upon completion, then I crossed the Orange River again and the Vaal River to come to the great University of Johannesburg, which has created the platform today. So I just thought I should just give you that glimpse, because some always think it tallies to my talk of being a villager. Yeah. So getting into the matters now at hand. So the talk is aligned to manufacturing. So in the modern world we live in, manufacturing is quite an important sector, which in this case contributes approximately 12% to the GDP of the country. In other countries, it actually contributes more. So we are aware now that sustainable goals is a big factor in everything that we do, and we're trying to make sure that we provide the good support, because the important thing is we are today because of the previous people, so we must also save the world for the upcoming ones, so that it's also safe for them. So I just put a puzzle there that whatever we do these days, there is sustainable development goals that we need to fulfill. Our talk, the talk is in manufacturing. In this case, I just thought for the benefit of the crowd, I just need to give you a glimpse of a typical manufacturing. In this case, is iron or steel, which comes from iron ore. Those that have went to Free State, they know it's the red soil that you'll need to process until you do a metal. I just thought I should start with that one, because my talk is mostly aligned towards this special materials called titanium. Similarly, the process is more or less the same, but now you don't get it from the red soil. Now you get it from the sand. The sand, South Africa is one of the countries that has that sand in Richards Bay. Of course, there's a back and forth in terms of policies and all the likes, but to make sure that things are sustainable. But it's one of the largest with a deposit of that. So, but the rest of the process is more similar to iron in terms of whether you're going to make a metal sheet or metal rod. So this is just to give you a glimpse, the interest of that material, which is called the alpha beta titanium, which is the mostly used material in the industry with regards to titanium, due to its good properties of corrosion and high strength to weight. So there are a number of applications of this material, ranging from biomedical, aerospace, and automotive. I'm sure some members have realized when others are traveling, there will always be a beeping sound when you travel, but they forgot that they've got an implant in their body, either being a tooth, or being a broken bone, or so this material is quite ideal for that, because your tissue can develop around it. So this is just to show, in automotive now there's a growing interest because everyone is crying about fuel consumption. So these materials are quite ideal because now it means your car, if you start using this, will start consuming less fuel. So I just thought I should also highlight who are the biggest consumers of this. You can see we've got a yellow patch there, which is still minimal compared to the rest of the world. But with this current deposit that we say we have, I think that is one of the sectors that can grow the economy. Because with more investors coming into play there, then there's more jobs that can be created. I've already spoken about this. You can see there is an interest in the usage of this in automotive or in cars, which will help your cars, especially now with the new car, EV cars or electric vehicles. Right. So that is just that about, so let me get into the welding. I'm sure you heard the dean saying I'm more into welding. So the journey actually started with the friction welding, which is just utilizing the friction welding process. Taper stud welding and friction surfacing. But the one that I followed was more friction stir welding. Due to its better processing, it is a process that you weld two materials without using an external source or external or filler material. In this case, two abutting surfaces, you rotate the tool on it, and then as the material plasticizes, then you traverse forward. So it is a process that was developed in 1991 by the known Dr. Wayne Thomas in the UK. So the rest of the world adopted it as it provided better usage in areas where you need to weld, especially for complex materials that could not be welded with conventional ways. So here I just indicating the complexity. Because it's a reactive material, you need to provide the shielding and all those inert gases so that the material doesn't react to oxygen. But if I may just skip that, go straight to, once the material, the components are welded, before you provide this, or industry adopts it, you need to provide testing. In this case, it was a fatigue testing in as welded condition or as polished conditions, so that you establish what is the main factor that influences your process. So with the as welded, meaning you just weld the material as it is and you apply it, so there was quite a increase, or let me just say, when you polish, the material develops, or you performs better than as welded. In this case, you can see the ones in the graph with the black one. So if you were to compare that with the, I think I just, okay. So most of the failures were due to inherent processes, like your defects or the surface, because the tool will be riding on top of the plates. The pictures there, that's just depicts that. I just thought I should. So similarly, we did a similar study, but now in this case is the laser processing. So it's still welding. So the idea, you want to compare the two to see which is the most alternative process in the case of titanium. This is just highlighting at various inputs what happens to the material when you apply your laser system. Similarly, the testing was done in the similar conditions to compare the two processes, so that you establish what is the most effective way to join titanium. So similarly, when the materials are polished, there's quite an improvement with the performance. So this is just showing you the material failures, where it comes from. You know, when you weld, at the root of the weld, that's where your failure starts from. But in other cases is where there's a gas entrapment due to laser, because laser has the material melts. So when you compare the two, you'll see just similar graphs which just represent that the two processes are actually comparable to a material that has not been welded. So when you remove all those, it means the process is very comparable to the as received material. So similarly, in friction or rotary friction, similar was done. Remember, the idea is to try to find the best process to join materials. So there's the work that was done on titanium as well. We call it Ti64, titanium 64 aluminum 4 vanadium alloy. Prof. Mashal could not pronounce that. It sounded very complex for him. So also we did similar work. This was now on stainless steel. This is just to establish what is the best work. And also we did fatigue. I could see one of my PhD graduate is smiling because you can see I used his slide here. He's sitting in the audience there. So most of the failures in this case was mostly from the misalignment of as the two components are being welded. So the work doesn't stop, it keeps continuing, because for a similar work we are trying to do residual stress measurements. How will this affect the fatigue in this case? Because we are aware every day whatever you are using is experiencing, or most of the things you are using, including a car, is some components are experiencing fatigue or dynamic loading on them. So there's always an interest to establish at what point will that component fail without causing a catastrophe. Hence, most components are given life, but some of us always say, no, it will hang in there, it will until a disaster happens. I always make an example with my students that have they ever ridden on being on a taxi, and then as they are in a taxi, then they catch up a spare wheel, meaning the wheel has come out of the car, but the driver doesn't tell them it's actually the wheel from this car you are riding on. So some of those things is due to fatigue failures that has happened, but the driver kept on going and say, we need to keep pushing because we need the money needs to come in. So the other area is with regards to development of composites. The new area is to develop new materials that can last longer than the previous ones without, or those that are not manufactured in a traditional or conventional way. So now we have the so-called laser metal deposition and also selective laser melting. In simple way is a 3D printing. In this case, it's metals, but mostly people know with plastic, but it's a similar concept. So this work has also been done. We have achieved quite success with the CSIR, or Council for Industrial Development, Industry Research. So some of the work has been presented in conferences and has shown better performance. So with the new world of developing materials, especially composites, we are trying to mix titanium and carbides to build a new material that will last a bit or perform longer than the traditional materials. So one of the greatest area as I began was sustainable goals are very important. With all this puzzle, you want to have a sustainable manufacturing that is economical, that is creating jobs, but that is energy safe, less waste. There's even new area, circular economy, you rework the components backwards. So in the modern world, there's nothing called waste. So everything can be reused. So, and at the end, we want it to be cost effective. So as I go further on additive manufacturing, there's quite a lot of applications that can be done in terms of additive manufacturing. I will not go one by one because you do have the print out there. It's just, yeah. So this additive manufacturing has shown growth in economy, and it still has the potential to grow the economy in terms of manufacturing. You can see in various sectors, this is now in million euros, how much is contributing into the economy, not necessarily South Africa, but the globally. So this is quite an important area in the modern times. I spoke earlier with when people had injuries. So this can help you now to have a tailored replacement of implants to different parts of your body. You can see on the slide they are just shown that 3D printing or manufacturing now has went into fashion because you can now print shoes. I made an example, the Adidas there. You can actually print your shoes that are style savvy in this case. There's also women clothes. I could only find a picture of women, unfortunately. So nothing wrong about. You can also the additive manufacturing. You save quite a lot of wastage because you only print what you are printing, and then you will just polish. So this has helped or reduced cost because in the manufacturing sector. Most of the components or most of the material goes to waste after you have done the actual or building component that you are building. Like I said earlier, we are trying to get to the sustainable processes. So all these components that we have done or that we have built in terms of additive manufacturing, one way or the other, you need to machine it. It needs to go and fit into something. So there's that need to investigate various machining processes because almost every component that fits, or let's take a car engine, you'll have to manufacture or you'll have to machine components to fit into something. So these materials are known to be very hard. So it is, as much as we are interested in the properties, it is very important to also know their impact in terms of machining, because now the machining now influences your environment in terms of your coolants, because you do have modern coolants, and then you can either recycle them, and in other undeveloped countries, they just dump it, and that affects the environment. So the world is getting into stricter areas or rules to make sure that we save the environment. I just thought I should just show, I just went the extreme. I just went to the extreme side of things to say coolants can, with a person constantly in manufacturing industry, the coolants can actually affect yourself if you inhale, or if you become or it becomes skin sensitive, you can react to them. So there's a new way to either use minimum quantity lubrication or cryogenic. That has shown that the surfaces are better improved. If I just take you there. So different trials you can try with try machining cryogenic or hybrid, which is a combination, to try to establish the better performance of your coolant, because at the end of the day, you want, depending on what components you're looking for, you want a better fitment. This is just reiterating the performance of different coolants. Similarly, you'll have to investigate the tools that you are using. Like I said, these are very hard materials, so you'll have to investigate the durability and the impact on the tools. This is just also reiterating what work has been done in that space. This was titanium. The previous one was, I think, stainless steel. So there's also a process on spark plasma sintering. At this stage, you're trying to develop new materials from powders. I'm sure earlier you saw there was an indication of titanium in the metal form or in the powder. There's an increase now with the titanium usage, because the powder usage, and there's more interest with various manufacturers to try to develop new materials. So spark plasma is one of them, where you compact your powder at elevated temperatures to produce components or material. It's always good to see some of the members who are very active into this technology who are here in the audience as well. I feel happy when I see them. So this is just to show different areas where this has been used and has produced various components. In this case, there has been production of gears or turbine blades. As the world is moving in manufacturing, everyone is very interested in the so-called developing of high-performance materials. In this case, we have the so-called high-entropy alloys. So I've indicated a depiction there that shows in yellow various high-entropy alloys, which performs very high compared to traditional materials. At this stage, this is still a developing material. Everyone in manufacturing is very interested into this, but they just have other complexities that, because now you have, instead of having in the previous case of titanium, aluminum, and vanadium, now you can see you've got a very complex nickel, iron, aluminum, titanium, chromium, and cobalt. And all of this, you want to combine it. Why is there interest in this? With now the development or use of AVs, everyone is very curious to know how we're going to store this hydrogen, or the hydrogen either for the cars or for the generation of electricity. We need to establish how to store them. So these are the kind of materials that will make sure that those are stored safely without compromising human life. So as you are at the great University of Johannesburg, which is very instrumental in AI in the country, so I found it very fitting to make sure that I have this slide, that we are working in this space to make sure, even though I'm in manufacturing, but all these are integrated in terms of machine learning, because various processes, you can create a system, instead of wasting a lot of time trying to make experience, that can be passed through machine learning and optimization. So, and this is a forever developing world, because today you see this, in the next few months you're gonna see some other developments. I just thought also there's with the AI, you can also predict even your surface finishes or images. So some of this work has already published, so if some of the members can be able to follow some of those profiles of mine, they will find all these items that I'm talking about. So I always say, in any situation, one cannot achieve what they are doing without collaborating with other members, either be locally or internationally. So, and this is actually a team effort. It's not one's achievement by themselves. Some members are here, some are online. So there's also a number of collaborators that has made sure this is possible. So I've picked some of those that make sure that I am where I am today. from my previous institutions to the current, to some that I've visited locally and internationally. This work has got a lot of people behind the scene. I've managed to capture some of their images. Some didn't give me permission, but I just had to take their images so that I can show that there is a contribution one way or the other from one of the members. So as I come towards the end, I would like to make some acknowledgements. Let me take this opportunity to give great appreciation to my wife. She's here, and the kids, Mto and Tandi. They are here on the audience for keeping up with my demanding journey right through. I've taken some of their special time, but they always had hope and believed in me and never gave up and assisted me in keeping me to push. They have seen some bad moments, good moments, and various changes in my career. I'm sure, and definitely sure, my success is their success. To my parents, who made sure they instill an idea of education in my head from an early age, they have indeed sown a great seed. They can surely pat themselves on the shoulder. They did a great job despite various challenges we had. These challenges have made me who I am today, and surely it doesn't end here. Surely my departed father will be smiling in heaven where he is. My mother is here to witness this achievement of the last born. And this is just a surety and to show even others, the upcoming generation, that this is possible. To my siblings and family, some are here, my brothers and sisters. Your presence and support to me from an age to now has been phenomenal, and it was vital and courageous. I thank you dearly for not giving up. So the Mashinini is quite a big family, so I will not mention their name. So I'll just say my brothers and sisters, my nephews and cousins, Abu Tatumngani, Mangani, Auntie, they are here. Burakhadi, thank you for your support. To my mentors, a great appreciation. You opened the doors for me and provided me with support and guidance when needed. And this has taught me a lesson that I must always support others, as our background is not always the same in this modern world we live in. You have helped to shape this new professor. Not forgetting the different colleagues. Some are here. They've played their roles in various areas. And they've shaped this journey to be what it is. So I do have a team I call it my students, some postgrad students. Some are at the entry level, some are towards the exit. It has been tough for me and you, but like I always say, you must never give up. So they know the phrase that I like using. There's always a light in the tunnel. It's up to you to see whether the light is coming towards you or away from you. But surely most of them have taken the fact that the light is coming towards them. Hence, the achievements that we have managed to achieve. So even to them, I say my success is their success, because I wouldn't be where I am if they were not there. So big ups to the research team. They know I always bother them with on the WhatsApp. As I close, God has made every moment to be special. Everything has a time and the right place. So I think this is the right time. And thank you for availing yourself to this inaugural lecture. Thank you, Kaleboa, Tangi.
Ladies and gentlemen, as we draw to a close, it is my honor to reflect on the enlightening presentation delivered by Professor Mashinini. Today, we have traversed through a landscape of advanced manufacturing processes, that is, welding, additive manufacturing, the machining of additive manufacturing materials, and high entropy alloys. Let's start with the highly cited topic, that is sustainable manufacturing. Sustainable manufacturing, basically, it is not merely a trend but a necessity in an area marked by climate change and resource scarcity. As Professor Machinini highlighted, welding processes, when optimized, can significantly reduce material wastage and energy consumption. By focusing on efficient heat input and material uses, welding technologies contribute to lowering our aligning with global efforts to mitigate environmental impact. Additionally, the additive manufacturing or 3D printing, also we can call it as a rapid prototyping technology. It is crucially explored in today's presentation, exemplifies a breakthrough in sustainable production. This technology enables near zero waste manufacturing by building components layer by layer using only the material required for the final product. This method not only conserves resources but also reduces the energy expenditures traditionally associated with sustainable manufacturing processes like machining, drilling, and milling. Furthermore, the ability to produce components on demand minimizes the need for large inventories, thereby reducing waste and enhancing resource efficiency. Uh, Professor Machinini also touched on the machining of additive manufacturing materials, a crucial steps in refining the precision and functionality of 3D printed parts. Here, sustainability can be enhanced by utilizing advanced machining techniques that minimize material removal and energy use. Through intelligent process planning and the integration of real-time monitoring system, we can further optimize these processes, ensuring minimal environmental impact while maintaining high quality and performance standards. In addition, high entropy alloys, another focus of today's discussion, represent a frontier in material science with substantial implementation for sustainable manufacturing. These materials, characterized by their exceptional strength, durability, and resistance to wear and corrosion, offer long service life and enhanced performance in demanding applications. By extending the lifespan of products and components, high entropy alloys contribute to a reduction in the frequency of replacement and replace, ultimately conserving resources and reducing waste. Finally, the Industry 4.0 and the future of manufacturing is also very promising topic. Professor Machinini insights also align with the broader framework of Industry 4.0, the ongoing resolution transforming manufacturing through digitization and smart technologies. The integration of advanced sensors, data analytics, artificial intelligence, and the Internet of Things into manufacturing processes heralds a new era of efficiency, precision, and sustainability. In welding, additive manufacturing, and the machining of materials, Industry 4.0 enables unprecedented level of process control and optimization. Real-time data collection and analysis allow for immediate adjustment to parameters, ensuring optimal performance and minimizing weight. Machine learning algorithm can easily predict and prevent defects they occur, further enhancing product quality and reducing material wastage. Moreover, the application of digital twins, a concept that involves creating a virtual replica of a manufacturing processes or product, enables manufacturers to simulate and optimize production scenarios without physical trials, thus conserving energy and materials. This virtual approach not only improves efficiency but also supports sustainable decision making by allowing manufacturers to foresee the environmental impact of their choices. Professor Machinini emphasis on high entropy alloys within the context of Industry 4.0 highlights another critical aspect, the ability to design and develop new materials with unique properties tailored for specific applications. Advanced computational tools and machine learning models can easily predict the behavior of these alloy under various conditions, accelerating the development cycle and ensuring that new materials meet both performance and sustainability criteria from the outset. In conclusion, Professor Machinini presentation has illuminated the path forward for sustainable manufacturing within the framework of Industry 4.0. By leveraging advanced technologies and innovative materials, we can achieve a harmonious balance between industrial advancement and environmental stewardship. The principle and practices discussed today not only enhance the efficiency of manufacturing processes, but also align with our collective responsibility to protect and preserve our planet for future uh, uh, generation. Let us take this insight forward, committed to advancing sustainable manufacturing practices in our work and industry. Thank you, Professor Machinini, for sharing your profound knowledge and vision with us today. And thank you, everyone, for being a part of this important conversation. Together, we can make a more sustainable and innovative future. Thank you, everyone.
So, so ladies and gentlemen, we come to the fun part, Professor Mashinini. The roping of Professor Mashinini. I would like to invite Professor Mashau to assist me with the roping of Professor. I think we should do it here.
Madindwa tikabela makhanda kodwa thula babulala umuntu bamhlaba kusabela amakhamba abamhlaba bakuhlala entanyeni kodwa ngokwakho sekuyadlanga bathola bathathwa libasha ngokhetha ingqonqo nomthingiza zathwala zawuza ishethi kathi zathi zathi yini laba ukuthi bathola ukuthi lishumi wahamba Madindwa hamba Professor wena Goliwe sizethu lishumi.
Now,
ababulala umuntu bamshaka bathi siwavulela amakhathama ababelelendeni lempongo zale abomhlali abuhlangani ngani kukoko mavasikehlangana abantwana bekhatheni bahle ngobathwala inqonqo nomsingizana zisezikaphesheya zathi omlotshwa umuntu kantangazi kuliwe ntozimandla.
thank you. As we are drawing to the close of this wonderful ceremony, I wish to congratulate you, Professor. Now, I wish I could say what has just been said. All I can say is skabela. Makhoza goduke. Mlotshwa. Inhliziyo ezilishumi. Congratulations, sir. Now, ladies and gentlemen, we invite you to go to the next room for refreshments, and thank you for coming to this great University of Johannesburg. It's been a wonderful, wonderful ceremony. Every time I see you, Prof, I'll think about materials and all of that, and welding, and then of course I'll ask you to help me pronounce those difficult terms. But congratulations once again, and thank you all of you for coming. You are invited.